Good day, students of economics. Welcome to another online video learning session. The concept covered in this particular video learning session is the economics of elasticity of demand. Think of elasticity of demand of an extension of knowledge you have already acquired through your study of markets. In our previous video, we covered the economics of markets, buyers and sellers, the interaction of demand and supply determining price and quantity in the market, equilibrium, the invisible hand, the rationing function of prices. So quick review. What is demand? It's a schedule of the various amounts of a good or service that buyers are willing and able to purchase, series of prices, specified amount of time, other things equal. So this schedule of price versus quantity demanded for a specific time for a good or a service or resource that buyers are interested in purchasing. And from our previous lessons, we remember there's this inverse relationship between price and quantity demanded. Economists refer to this as the law of demand. So if the price of a good or a service or a resource was to fall, we would expect buyers to purchase more. Quantity demanded will rise. If price were to rise, the price of a good or a service or a resource goes up, there'll be a decrease in quantity demanded. Elasticity is going to measure the responsiveness. So when we covered this law of demand, when we introduced demand in the previous video learning session, we didn't get into the specifics of, okay, if price falls, do buyers purchase a whole heck of a lot more or just a little bit more? If price rises, do buyers jump ship and buy hardly anything, or do they buy just a little bit less? That, my friends, is the idea of elasticity of demand. How responsive are buyers to changes in prices? So we're not going to violate the law of demand. We know that if price declines, there'll be an increase in quantity demanded. And if price rises, there'll be a decrease in quantity demanded. It's really a question of how responsive are buyers to changes in price. So we're going to come up with two fancy terms to explain how responsive buyers are to price changes. If buyers are quite responsive, that is to say, price declines and buyers purchase a whole bunch more, we say demand is elastic. If buyers are not all that responsive, we say that buyers are inelastic. So there's our two ideas. Elasticity of demand is expressed by saying demand for this product or this service or this resource is either elastic, that is to say buyers are responsive to change in price, or it's inelastic, buyers are not all that responsive. Remember, we're not violating the law of demand, and we'll see this on the next slide, that there's always going to be some response by buyers, except in the rare case. We're really measuring how responsive are buyers to change in price. So get familiar with these two terms, elastic and inelastic. We say that demand for some product or service or resource is elastic, then we would expect that a change in price is met by a significant change in quantity demanded. If we say that demand for a resource, a product, or a service is inelastic, then when price changes, there's not all that much response from buyers. What we've been talking about quantitatively, now let's look at quantitatively with the economist's favorite tool, the graph. So here we have two demand curves. On the left-hand side, we have a rather elastic demand curve. And on the right-hand side, we have a rather inelastic demand curve. So the shape of the demand curve tells us something about elasticity. Notice that the demand curve on the left is relatively flat, and the demand curve on the right is relatively steep. Just by looking at the shape of the demand curve, we can comment on elasticity of demand. So the more flat a demand curve, the more elastic demand, more responsive buyers will be to changes in price. The more steep a demand curve, the more inelastic, the less responsive buyers are to changes in price. So now we can understand why this information is important to economists. Economists want to know how responsive buyers will be to price changes. So for instance, if you're running a business, you're going to want to know, if I decrease the price of the product or service I'm offering to consumers, will buyers purchase a whole heck of a lot more or just a little bit more? And there's going to be other applications for this concept of elasticity of demand as we go through our lesson. One note, slope and elasticity are not the same thing, but again, the shape of the curve tells us something about elasticity. Economists have identified 4 characteristics or determinants of elasticity of demand. The first one is the number of substitutes or substitutability. And this is what economists have discovered. When there are a large number of substitutes for a product, a service, or a resource, the demand for that product, service, or resource will be rather elastic. That is to say, consumers will be quite responsive to changes in price. When there are few substitutes, demand will be rather inelastic. That is to say, price changes quite substantially, there'll be only a small percentage change in quantity demanded. A few practical examples will help reiterate the importance of this particular determinant of elasticity of demand. Think of a product or service for which there are few substitutes. Gasoline. We do expect the demand for gasoline to be rather inelastic. That is to say, buyers are not all that responsive to change in price. And we see this happen out in practical observation of what happens in the world. When the price of gasoline over the post-COVID world increased from $2.10 a gallon up to $3.70 a gallon, people still drove to work and they still drove to school and they still drove to the places they had to drive. They cut out on any unnecessary driving. So some response, but not a huge response to change in price. Demand for gasoline is rather inelastic. Utilities. Think about your natural gas or your electric bill at home. When it's extremely hot outside, you don't really have a choice to run your air conditioning on anything other than electricity. So when electricity goes up in price, you can't really find a substitute for that service. So the demand for utilities tends to be rather inelastic. Same thing with tobacco products such as cigarettes. There aren't a large number of substitutes for cigarettes. The demand for cigarettes is rather inelastic. This last example is going to have applications when we talk about the practical rationale of understanding elasticity and government's decision to tax certain goods. Proportion of income. The more an item costs, the higher the ticket price on the item. The larger percentage of the buyer's income, the more responsive buyers are to change in price. The smaller the price of the good or service, the less responsive consumers are to change in price. So think about an automobile versus a container of table salt. An automobile could be 1 year's salary or more, a rather expensive item, a high proportion of buyer's income. We do expect the demand for automobiles to be rather elastic, as opposed to something like table salt. When you go to purchase it at the supermarket, it's such a tiny fraction of your income, you don't even care if it went up in price by 80%. You're going to buy it anyway because it costs so little to begin with. So big ticket items demand elastic, buyers are responsive. Little ticket items, small ticket items, demand for those is rather inelastic. Do you need it or do you just want it? Luxury versus necessity. The more necessary a good or a service, the more buyers are forced to purchase that good or service regardless of the price. So we would expect the demand for necessities to be rather inelastic. That is to say, buyers are not all that responsive to price changes. If a good or a service is more of a discretionary type of spending, it's a luxury, it's not a necessity, things like going on a cruise, even things like dessert where you don't need to buy dessert, we would expect the demand for those luxuries to be far more elastic. Buyers are far more responsive to changes in price. And finally, time. The more time buyers have to adjust their habits, the more responsive they will be to change in price. In the short run, we find that demand for goods and services is rather inelastic. A good example of this is when you go to a ball game or a concert or a show and you want to purchase a bottle of water, and yes, you're infuriated that it costs $6 because you know you can buy a case of water for $6. But over that short period, you want the water, you need the water, you're thirsty then. So the demand in that specific setting, that time frame, that short run, for that demand for a bottle of water is going to be rather inelastic. Buyers are not all that responsive to change in price. Given more time to adjust, demand will be rather elastic. Buyers will be more responsive. We've been talking about elasticity of demand and the characteristics of elasticity of demand. Now let's discuss the tools economists have developed to measure elasticity of demand. Economists have two tools at their disposal used to measure elasticity of demand. The first tool used by economists to measure how responsive buyers are to change in prices. What's the responsiveness to price changes is called the price elasticity coefficient. Students hate math. Even the name suggests it's going to be a math-oriented approach to measuring elasticity of demand, and yes, it's a mathematical approach. Technically, we're measuring percentage change in quantity demanded over percentage change in price. When we review this formula in more detail shortly, we'll talk about why percentage change is important. We'll even talk about measuring elasticity over a price range and the need to use an even more complicated formula known as the midpoint formula. Long story short, because this is an intro class, even though the math will be introduced to students, far more important, you can interpret the results. In other words, if you were given the coefficient of elasticity, the price elasticity coefficient, just by looking at the number, you should be able to interpret that number based on the understanding economists have developed. The second tool used by economists to measure elasticity is the total revenue test. So in addition to the coefficient of elasticity or price elasticity coefficient, we've developed this total revenue test. This one is a precursor to many microeconomic concepts to follow, especially when we start talking about market models and we talk about pricing power of the firm within a specific market model. So the second tool used by economists is the total revenue test. Let's look more formally at the first tool used by economists to measure elasticity or responsiveness to price change. Economists are trying to determine whether demand is relatively elastic, that is to say, buyers are rather responsive to price change, or whether demand is relatively inelastic, that is to say, buyers are not all that responsive to price change. Again, this mathematical approach, the coefficient of elasticity, the formula, percentage change in quantity demanded over percentage change in price. So when calculating elasticity of demand using this coefficient of elasticity formula, we're going to measure percentage change in quantity demanded over percentage change in price. On the previous slide, the coefficient of elasticity of demand formula was introduced, and economists are measuring percentage change in quantity demanded over percentage change in price to calculate the coefficient of elasticity. However, over a price range, there are issues. Therefore, economists have to average out these mathematical adjustments using what is known as the midpoint formula. An example will help understand what I'm referring to. If price of a good or service increases from $1 to $2 and quantity demanded drops from 8 to 7, what are the percentage changes? Well, a $1 to $2 increase is a 100% increase in price, and from 8 to 7, that drop is 1/8 or 12.5%. But what if the opposite occurred? What if price went from what if price dropped from $2 to $1, now a 50% decline, and quantity demanded increased from 7 to 8, slightly more than, it's about a 14.28% increase in quantity demanded. Economists realize, geez, we have to take into consideration over a range between $1 and $2 using averages by implementing what's called the midpoint formula. So down bottom you see this formula more formally. To calculate elasticity over a price range, we take the change in quantity divided by the sum of the quantities divided by 2. We take that number and then divide that whole thing by the change in price over the sum of the prices divided by 2. Again, introductory course, I'm certain all college students could work this math out if necessary. Far more interested in interpreting the coefficient of elasticity. Some final important thoughts about the coefficient of elasticity as a measure of elasticity demand. First, percentage change in quantity demanded over percentage change in price. Why percentage change as opposed to absolute changes? Well, if the price of a yacht increases from $1 million to $1,001,001, does it really matter? As opposed to the price of a candy bar increasing from $1 to $2, that's a 100% increase in the candy bar. And economists trying to make sense of the candy industry might start asking questions. Why was there a 100% increase in the price of the candy bar? Was this just one brand or all brands? So percentage changes make much more sense because we can make much better economic interpretations of the data using percentage change in quantity demanded over percentage change in price. Another important idea, remember the law of demand. There's an inverse relationship between price and quantity demanded, right? Price increases, quantity demanded will decline. Price declines, there'll be an increase in quantity demanded, right? So price up, quantity demanded down. Price down, quantity demanded up. Same thing with the percentage changes, right? You think, okay, if there's a 20% decline in the price, there's going to be some increase in quantity demanded. So either our numerator or our denominator is going to have a negative sign, right? If price is down by some percentage, quantity demanded will be up by some percentage. And if price is up by some percentage, quantity demanded will be up by some percentage. Economists, just out of the idea of efficiency, say we don't need the negative sign. We'll take the absolute value of the interpreted data, of the number that we calculate using the coefficient of elasticity. Now the most important, interpreting the coefficient of elasticity of demand. Economists have developed a rule. If the coefficient of elasticity is less than 1, demand is inelastic. If the coefficient of elasticity is more than 1, demand is elastic. So if we think about, okay, we're given information that says elasticity coefficient for this product or this service is 2. Well, then we know it's elastic. And then we said, okay, well, compare that to a product where the coefficient of elasticity is 5. Well, 5 is greater than 2, so therefore demand is even more elastic if the coefficient of elasticity is 5 relative to 2. So any coefficient of elasticity greater than 1, buyers are responsive. Demand for that good or service or resource is elastic. Anything less than 1, buyers are not all that responsive. Demand is inelastic. Now, there could be a rare case where there's a 20% decline in price and it's met with a 20% increase in client demand, or vice versa. A 30% increase in price is met by a 30% decline in client demand, where the coefficient comes out to exactly 1, and we call that unit elastic. Let's talk about the rare or extreme cases. Our first graph here is a vertical demand curve. Economists refer to this as a situation when demand is perfectly inelastic. Interpret the information conveyed by this graph. If we look and say, okay, what if demand is perfectly vertical at, let's say, quantity 50? So if we look on the horizontal axis, this demand curve is straight up at 50. How do we interpret this? What's going on here? We say, well, it doesn't matter if you charge a penny, $1, $5, $50, $100. Quantity demand, it will be the same regardless of the price. So in this case, demand being perfectly inelastic, there's absolutely no response from buyers in regards to change in price. So you could be giving this away for a penny a piece, or you could be charging $100 per unit, and buyers will purchase the same amount. Can you think of any situation on earth where that's the case? Well, the only, we'll say, somewhat realistic example of this is, say, what if you are diabetic and your doctor told you to take 50 milligrams of insulin per day? Now, you don't care if they were giving it away or it cost you $100. You're going to take 50 milligrams if that keeps your blood sugar level at the proper level, right? You don't care what it costs. Now, of course, that's the rather extreme case. We do see that the demand for prescription medicines is highly inelastic. But you also see, unfortunately, sometimes seniors on fixed budgets have to make choices and will cut some of their pills in half because they simply can't afford all of their medications. So the perfectly inelastic demand curve, an extreme rare situation. What about the other case? We look at this graph of this demand curve. Instead of it being perfectly vertical, it's perfectly horizontal, and therefore it's perfectly elastic. So what's going on here? Well, let's assume here that price is $5 per unit at demand, where that demand curve is perfectly elastic. This perfectly elastic demand curve is actually going to have applications for our microeconomic studies moving forward when we discuss a single seller, one firm competing in a purely competitive industry where they are what is referred to as a price taker. So think of thousands of corn farms. Every farmer sells the same exact product, and the product price is determined by the market. One single farmer's contribution to the total market output is so negligible that they have no control over price, and because they're selling the same product as their competitors, they really can't raise or lower price. It would make no, right? So in this case, demand is perfectly elastic for the single seller competing in a purely competitive industry. Definitely revisit this perfectly elastic demand curve in the future of our microeconomic studies. Let's examine our second tool used by economists to determine elasticity of demand, the total revenue test. Before we look at this graphically and explain the relationship between price and total revenue and how we interpret that information in terms of elasticity of demand, we need to explain what is total revenue. Total revenue is rather straightforward. A firm sells some type of product at a certain price, and of course they sell a certain quantity of these products. Therefore, total revenue is price times quantity. Let's say that we sell fidget spinners, those things that kids loved for a while there. We sell them for $8 a pop. We sell 1,000 of them a week. So our revenue for the week, our total revenue is 8 times 1,000, 8,000. That's what we mean by total revenue. Definitely going to use this information moving forward in our study of microeconomics, total revenue. Good to get this economic concept under our belt now. Now, how about the total revenue test in terms of elasticity of demand? Let's assume that demand for a product is rather elastic. Again, if we just look at this curve, we looked at a curve similar to this earlier in the video. If a curve is relatively flat, a demand curve is relatively flat, just by looking at the shape of the curve, we can interpret this and say, demand for this product is going to be rather elastic. That is to say, buyers are going to be quite responsive to changes in price. Well, what does the total revenue test tell us about elasticity of demand? If demand is elastic, price and total revenue move in the opposite direction. So currently, this firm is selling units of output at $2, and they're selling 10 units. So if we look at that rectangle, the area of that rectangle, where we take price, $2, times quantity, 10, total revenue is 20. So the firm is wondering, is it a good idea to lower price? Will that be good or bad for the revenue, the total revenue that the firm collects? Well, when demand is elastic, price and total revenue move in the opposite direction. So the firm lowers price. We know that by lowering price, they'll sell more. The question is, how responsive are buyers to change in price? This firm lowers price from $2 to $1 per unit. Because demand is elastic, buyers are quite responsive. Buyers increase quantity demand from 10 to 40. So at price 2, quantity demand was 10. At price 1, quantity demand is 40. Remember, when demand is elastic, price and total revenue move in the opposite direction. So in this case, a decrease in price is met with an increase in total revenue because demand is elastic. That's what the total revenue test tells us. Another important idea here. What if we considered this from the opposite perspective? What if the firm was selling units at $1 per price? $1 per unit. $1 price per unit. They were selling 40, and they came up with this idea of saying, you know what? We're going to raise our price. Remember, if demand is elastic, if buyers are responsive, price and total revenue move in the opposite direction. By increasing the price, the firm actually collects less in total revenue. An important idea, some people wrongly assume that firms can raise prices and always make themselves better off. That's not the case when demand is elastic. Something to consider moving forward when we talk about the different market models. Does a firm have pricing power? Is it wise for them to raise price? We just learned if the demand for their product or their service or the resource they sell is elastic, raising price is a bad idea. Increase in price decreases total revenue. Now let's examine the relationship between price and total revenue when demand is relatively inelastic. Again, notice the shape of this demand curve, a relatively steep demand curve. Already interpret the graphic expression of the relationship between price and quantity demanded here. A rather steep demand curve. Demand is going to be inelastic, that is to say, buyers are not all that responsive to change in price. When demand for a product is inelastic, price and total revenue move in the same direction. When demand is inelastic, price and total revenue move in the same direction. So a decrease in price is going to be met with a decrease in total revenue, and an increase in price the opposite. So this firm is currently charging $4 per unit. They're selling 10 units of output. 4 times 10, total revenue of 40. They decrease price. Will they sell more? Of course. Inverse relationship between price and quantity demanded. The question is, how does it affect their total revenue? Well, a decrease in price from $4 to $1, they sell 10 more, but look what happened to total revenue. At the new price, $1 per unit, 20 units sold, total revenue dropped from 40 to 20. But again, considering this from the opposite perspective, if the firm started at a price of 1, charging customers $1 per unit, and then they increase price to $4, notice they would sell less, but they'll actually increase total revenue. So when demand for a product is inelastic, price and total revenue move in the same direction. Price declines by 30%, quantity demand increases by 30%. Price increases by 30%, quantity demand decreases by 30%. Let's finalize our discussion of the total revenue test by revisiting that rare instance when we have what's called unit elastic. Percentage change in price is met with an exact same percentage change in quantity demanded. In this example, the firm is currently charging $3 per unit, selling 10 units, and decides they're going to decrease price to $1 per unit. And by doing so, they sell 30 units. If we compare the total revenue at $3 versus $1, notice that total revenue is the same regardless of the price, because percentage change in quantity demanded was equal to the percentage change in price. Again, this is a rare occurrence. Having introduced the coefficient of elasticity and the total revenue test as the two measures of elasticity of demand, it's important to evaluate a typical downward sloping demand curve. In the previous examples, use some extreme cases to demonstrate points, but it's probably a good idea to make sense of our typical downward sloping demand curve. So as pictured on the slide here, this demand curve, it's not super flat, which means it's not a situation where demand's obviously elastic, and it's not extremely steep, so it's not a situation where demand's relatively inelastic. It's somewhere in between, which we would call the norm. So if we look on this demand curve at points between points A, B, and C on this demand curve, we're going to notice that in this region of the demand curve, demand tends to be relatively elastic. That is to say, buyers are quite responsive to change in price. And we can prove this mathematically by thinking about percentage change in quantity demanded over percentage change in price. Again, calculating that coefficient of elasticity, especially using the midpoint formula, is a bit much, but it's straightforward enough here to explain this. If you look and say, okay, what goes on from between point A and point B? Well, demand increases from 5 to 7, right? That's 2 over 5. That's a 40% increase in demand, right? So that's a pretty large numerator relative to the change in price. When price drops from 60 to 50, that's a 1/6 drop. So that's typical of your typical downward sloping demand curve, where percentage change in price, the numerator, is quite small in that range of the demand curve. Percentage change in quantity demanded is quite large. Therefore, our coefficient of elasticity is going to be a number greater than 1, hence demand is elastic. In the lower right-hand region of our demand curve, if we look on this specific demand curve, from C down to E down towards E, the opposite is taking place. Percentage change in quantity demanded much smaller, percentage change in price much larger. Your typical downward sloping demand curve in this lower right-hand region, we're going to notice that demand tends to be relatively inelastic. Now, why is this important is because further down the road, we're going to talk about things such as a monopolist having pricing power, and a monopolist saying, hey, if we can control price, we can make certain that we want to set demand in the elastic region of the demand curve such that we know that by lowering price, we're not going to decrease total revenue. Things to think about moving forward. But the most important observation here, your typical downward sloping demand curve is going to have have both an elastic region and an inelastic region. Another point before we move on to our final evaluation of this video on elasticity demand. Elasticity is not the same thing as slope. If we look at these two demand curves parallel to one another, if you ask a mathematician, do both of these lines have the same slope? I'm sure you remember from your introductory algebra course that any two parallel lines are going to have the same slope. But they don't have the same elasticity of demand. Why is that? It's because there's a unique relationship between price and quantity demand on each demand curve. If we look at demand curve labeled D relative to D1, and we look in those red arrows sort of showing you an increase in demand, a rightward shift in the demand curve. So, okay, if price was $9 on demand curve D, we said there's a specific quantity demanded. Well, that's not going to be the same as on demand curve D1. So every demand curve has a unique price-quantity relationship. Therefore, it alters the coefficient of elasticity of demand to some extent. But, good review, both of these typically downward sloping demand curves hold the properties introduced on the previous slide, that they're both going to have a relatively elastic region and a relatively inelastic region. A fictitious movie theater example will help reinforce important concepts related to elasticity of demand. So assume this is the movie theater on a college campus, and they're facing a certain demand schedule, and they're deciding what's the perfect pricing for the movie tickets for college students. Columns 1 and column 2 provide the demand schedule for this fictitious campus movie theater. Column 1 is quantity demanded. Those are in thousands, so you see those 1, 2, 3, 4, 5, 6, 7, 8, those are per thousand. And column 2 is simply the price per ticket. So deciding to charge somewhere between $8 per ticket and $1 per ticket. Again, understand that calculating coefficient of elasticity demand, percentage change in quantity demand over percentage change in price is tedious. Understanding even further, implementing the midpoint formula is even more cumbersome mathematically. Understand the importance of interpret the coefficient of elasticity. However, I do challenge students, calculate one of these on your own so you can see, you can visualize, you can get a good feel for the math of where these numbers are coming from. Remember, the midpoint formula, you take the change in quantity over the sum of quantities divided by 2. All of that divided by the change in price divided by the sum of the prices divided by 2. Not difficult math, just time consuming really. But let's interpret the data. Let's interpret the coefficient of elasticity. Notice that between a price range of $8 and $7 per ticket, demand is rather elastic. That is to say, buyers are quite responsive to change in price. A coefficient of elasticity of 5 over that price range. And then notice that the coefficient of elasticity declines as we move down the price range. Remember, your typical downward sloping demand curve is going to have both an elastic region and an inelastic region. When we interpret the coefficient of elasticity at lower price levels, say between $5 and $4, or even between $4 and $3, we notice that demand has now changed from elastic to inelastic because the coefficient of elasticity is less than 1. So column 3, the coefficient of elasticity, and that was determined using the midpoint formula. Column 4 is total revenue. So if you were given the total revenue information, you could easily determine elasticity of demand. If you look at one price, say $7 per ticket, and say, okay, the firm increased price from $7 per ticket, well, did total revenue increase or decrease? Well, total revenue for the firm was $14,000 when they were charging $7 per ticket. When they increased price to $8, total revenue falls from $14,000 to $8,000. Price up, total revenue down. That means demand must be elastic. That is to say, buyers are responsive to change in price. So remember, when there's an inverse relationship, when price and total revenue move in the opposite direction, demand for that good or service is elastic. The opposite is true when demand is inelastic. Price and total revenue move in the same direction. Notice, say, okay, this movie theater is thinking, hey, if we increase price from $1 to $2, what will happen to total revenue? Yeah, fewer people will come to the theater because at $1 per ticket, 8,000 students visit the theater per week. At $2, only 7,000 students visit the theater per week. But price up, total revenue up. Price and total revenue move in the same direction. Demand is inelastic. Okay, here's a good question. Just from looking at this data, what price should the firm, in this case, our fictitious movie house, what should they charge? And you say, well, they really have two choices. This firm could charge $4 per ticket and expect 5,000 visitors per week, thereby collecting $20,000 in total revenue. Or they could charge $5 per ticket and expect 4,000 visitors, thereby collecting the same $20,000 in total revenue. So between $4 and $5 per ticket, economists would interpret this as demand is unit elastic. Demand is unit elastic over that price range. For the past 40 minutes or so, we've been explaining the important concept referred to as elasticity of demand. By graphing the fictitious movie theater's demand schedule and total revenue schedule on the same slide, we can examine elasticity of demand one more time to reinforce some important ideas. So the top graph here is simply the fictitious movie theater's demand schedule. For the campus movie theater, we have these various amounts of good or service, in this case a service, that buyers are willing and able to purchase, series of prices somewhere between $1 and $8, specified amount of time, and that is this week, the firm's demand schedule. Understand that your typical downward sloping demand curve has both an elastic region and an inelastic region. Down bottom, we simply graph the firm's total revenue. This will result in a parabola which demonstrates the price times quantity outcomes for each various pricing point for the firm. In the upper left-hand region of the demand curve, coefficient of elasticity is greater than 1. Demand is elastic. Buyers are responsive to change in price. When demand is elastic, price and total revenue move in the opposite direction. Notice that as the firm lowers price, the firm's total revenue actually increases. So by lowering price, they sell more tickets. Buyers are responsive to change in price. Unfortunately, the firm can't expect to lower price forever and continue to increase total revenue. At some point, they reach that portion of the demand curve in the middle where demand is what we call unit elastic. Percentage change in price is met by the exact percentage change in quantity demanded. Economists refer to this as the point of indifference. So the firm says, oh, we're indifferent. We could charge $5 per ticket and have 4,000 visitors per week, or we could charge $4 per ticket and have 5,000 attendees to our movie theater per week. Either way, we're going to collect $20,000 in total revenue. The lower right-hand region of the demand curve tends to be the inelastic portion of the demand curve. Price and total revenue move in the same direction. Coefficient elasticity is less than 1. Buyers not all that responsive to change in price. Right? So should the firm continue to lower price if they started at $4? No, because they'll make themselves worse off. Yes, more people will visit the movie theater, but the firm's total revenue will decline. Now, obviously, we could take the opposite approach and say, hey, what if this is the first week we opened the movie theater and we only charged $1 per ticket and people were very excited about visiting the theater, and 8,000 students visited the theater. And then we got this bright idea: should we raise price? Let's raise price from $1 to $2. Yes, by raising price when demand is inelastic, what? Price up, total revenue up. I unfortunately can't play that game forever. I notice that beyond the price of $4, demand begins to turn from inelastic to elastic. The basic information introduced by this simplistic example is applicable to our study of market models moving forward. So even though the fictitious movie theater might not be the most exciting of all examples we could have introduced, when we study pure competition, monopoly, monopolistic competition, and oligopoly, definitely revisit elasticity of demand and discuss in detail the importance of a firm understanding if demand for their good or their service or resource is elastic or inelastic, and how that will affect the firm's pricing strategy. An examination of 4 practical applications of elasticity of demand will reinforce the importance of this concept. Consider the first 3 and the markets under consideration: large crop yields, agricultural products; taxation on tobacco and alcohol, so cigarettes and alcoholic beverages; and illegal drugs, illegal narcotics. The demand for these items tends to be highly inelastic. That is to say, buyers are not all that responsive to changes in price. When demand is inelastic, price and total revenue move in the same direction. Large crop yields. Will a bumper crop, will a tremendous growing season make farmers better off? The answer is not necessarily. Tremendous growing season where output exceeds expectations, increases supply, rightward shift in supply drives down price. The demand for agricultural products is inelastic because consumers view these as a necessity. Buyers are not all that responsive to change in price. Price and total revenue move in the same direction. Lower price can inevitably lead to lower total revenue collected by farmers. Therefore, large crop yields are not necessarily better for the agricultural industry. Why do governments tax cigarettes and alcoholic beverages? Taxation on tobacco and alcohol products are winners for politicians. Politicians understand buyers of these items are addicted somewhat to these types of products. Consider 100 smokers. If the state government decided they're going to levy an additional $2 per pack on a tax of cigarettes, out of that 100 smokers, how many will decide it's time to quit smoking? 8, 9 maybe? Greater than 90% of smokers will continue smoking. An increase in the price increases tax revenues collected by governments, and the same is true with alcoholic beverages. Citizens who purchase spirits will not be deterred even by a 50% increase on the taxation on alcoholic beverages. Illegal drugs. Everyone recognizes narcotics ruin lives, ruin society. Difficult to say with any degree of confidence that current policies have been highly effective in regards to removing illegal narcotics from the streets. About the same percentage of Americans today use illegal narcotics as they did 20, 30 years ago. That's why some governments in Europe have considered unique approaches to dealing with these problems. The demand for heroin is highly inelastic. Buyers are not deterred all that much by change in price and will actually undertake illegal activities to consume their illegal drugs. That's why European governments have started programs where they actually give heroin to addicts. This sounds ludicrous, but addicts must sit through counseling and listen to strong, solid, sensible advice about getting your life back together by removing yourself from this addiction to this horrific illegal narcotic. Nothing else has worked all that well thus far. Demand for illegal drugs is highly inelastic. It's probably time to take a new approach to dealing with this socioeconomic issue. The minimum wage debate. Is the demand for low-skilled workers relatively elastic, as pictured on the left, down bottom here, this graph on the left, or is the demand for low-skilled workers relatively inelastic, similar to the other three items just discussed? Remember, in the labor market, buyers are businesses and sellers are households. Price is the wages collected by low-skilled workers, minimum wage workers. If demand for minimum wage workers is relatively elastic, any increase in the minimum wage will result in a significant decrease in demand because demand is elastic. Buyers, businesses will purchase less workers, which means less total revenue, in this case less wages collected by members of the low skilled jobs, and fewer workers will be employed. If, on the other hand, demand for low skilled minimum wage workers is relatively inelastic, an increase in the minimum wage will actually be effective because buyers won't be all that responsive to the government increase price, and therefore workers will be made better off with higher wages, and only a few jobs in those industries will be lost. Definitely things to consider, and this emphasizes the importance of microeconomic principles and their practical applications. Thanks for listening. See you in a future economic lesson.